Hello everyone, welcome to another very important session which is part of your ongoing series where we are talking about revision, 1 marker, 2, 3, 5 marker questions for PU2 maths for midterm examination, right? So today's session is on what you all know is the rapid revision of the chapter determinant. But just because it is rapid doesn't mean that we'll skip anything, okay? Yes, we'll have to cover up everything quickly. I have to give you a summary of all in very brief, but do not worry, I'll not skip anything. That's a promise, and also I'll not skip explaining in the concept as well, okay? So I'll certainly explain all the concepts in detail in this rapid revision session, okay? So starting first thing, we'll talk about thodi basics. We'll learn small things about determinant. What is a determinant and how is it different from matrices? Okay, they are different. We all know that matrices was arrangement of data, okay, or functions. We used to write sine, cos and all that in the matrix as well. So if you write the arrangement itself, just the rectangular array, that was your matrices, okay? But in the case of determinant, we have a value. This is either a scalar value or it is a expression. Sometimes it also comes out as expression. If you solve the functions right, let's say the given matrix for a square matrix, of course, is given in terms of variables or functions. If you find determinant for that, you'll end up with an expression, right? So determinant can either be a scalar value or expression. One more thing, as I said right now, only associated with square matrix. Means you can find determinant only for a square matrix. Okay. Another point, anything else? They are different, right? Matrix was only rectangular array. It means matrix we can have 2 cross 3 order, but in determinant we cannot have 2 cross 3 order. We must have 3 cross 3 or 2 cross 2. Okay. What else? We have elements, remember, like this. Let's say if you have 2 cross 2 matrix, the element was written as A11, A12, A21 and A22. Yes, you have to remember these elements. They are very important, because when we talk about our cofactors, our minors, our adjoint, then all of this comes to the picture. We have to understand all these concepts. Then do not worry, I'll tell you that in detail later, but right now please remember that's how we write a 2 cross 2 matrix. We can also go ahead and write 3 cross 3 matrix as well, okay, same fashion. Yeah, most of the time we're going to use 2 cross 2 and 3 cross 3 matrix. We'll not go for 4 cross 4 in our syllabus, okay? Even for KCET, we don't go and learn 4 cross 4 matrix. 3 cross 3 is more than sufficient to get your any marks coming in the chapter of determinant, okay? So 2 cross 2, 3 cross 3, again it will be A11, A12, A13 and so on. Why this number 1, 1, 1, 2 is important? Because when they add up to even, there's some property. When they add up to odd, like 1 plus 2 is odd, right? That is 3. So that causes a different property in the case of cofactors, okay? A 1 plus 1 is even, then there's a different property as well. So this is called as basically AIJ, okay? This is AIJ represents your elements. If I write here, I'll tell you this again later. If I write here MIJ, it will represent your minus, and your CIJ or capital AIJ will represent your cofactors, okay? Cofactors. All right. So some of the important and very basic point about determinant, okay? Now we'll see the properties, don't worry. We'll see the properties of determinant where the questions are very much direct, that is there. But right now some very basic things. Let's move on. Number of elements in determinant. How do you find that? Okay, in any determinant, let's say determinant of A, all right, how many number of element will be there? Okay, if order is let's say n, order is n, they're asking us to find the number of element. Okay, how do you find that? It's always going to be equal to n square. Basically, if it is the order 2, it will become 2 square. How much is that? 4. Check the number of element. 1, 2, 3, 4. If the order value is 3, number of element will be what? N square means 9. Check here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't this how you write it? 3 rows, 3 columns, correct? Okay. Now one more thing. Determinant is not multiplied as you used to multiply in case of matrices. Remember, if I asked to multiply matrix A into matrix B, we had a property to remember, number of rows over, so number of columns over here equal to number of rows. But in this case, there is a way to multiply determinant directly, but you don't have to learn right now. It's not there in the syllabus. You have to remember, find the value of determinant. This is a different thing, okay? You know how to find this, but this, if it's written like this, you don't have to multiply them directly, just find the value of determinant of A and B, okay? And once you do that, use the values product actually, okay? Use the value for the product. But yes, there is a way to multiply determinant, but not in the syllabus. That's what I'm not teaching you. Just remember, if you want to do that, you have to keep the order same. In this, the property was that number of column, number of row should be equal. If you want to multiply the directly determinant, the rules will remain same as the product. In case of matrices, just the order will have to be same for both the matrix. Okay, clear? Very basic things, very basic thing, nothing else is there in this first slide. We'll move on, we'll learn more things. Okay, next we'll talk about minors and cofactors. If I tell you your entire chapter in some way revolves around these two, you'll not believe it. If you have learned the chapter, you will know this for sure. Okay, the cofactors are one of the most important concept when it comes to determinant. Very important. Whether you talk about adjoint, inverse, anywhere you go, cofactor picture will come back, and if you don't know, haunt you. If you know, then yeah, good for us. Okay, so not only that, I'll give you tricks to find the cofactors and the adjoint easily for your 2x2, 3x3 matrix. Okay, let's get back to it. So let's say if I have a matrix A written like that, A11, A12, A21, A22, okay, then the minors is nothing but, if I'm writing the minor of what, see the element here, M11. Minor means for any element, for every element there will be a minor. Okay, for the first element the minor will be, you remove this and this, the element which is left is called as minor, A22. If I talk about this one, you remove these two, this is the element left, so A21. Okay, so that is your minus for the respective elements M11, M12, M21 and M22. Okay, clear? And now we are going back to what? We are going to the world of cofactors. Look, if this sum, if the sum of I plus j is even, what is I? The position of the number of rows involved, and j represents the number of column, right? So when I plus j is even, the minor and the cofactor are the same. Please check, A11 M11 is same as A22. So here A22 is same as M22. But if the sum is odd, 1 plus 2 is 3, 2 plus 1 is again 3, so odd, then the sign of the minor reverses. That's why we have a minus M12. That's why we have a minus M21. Okay, so whenever you have the sum of I plus j, where I represents your number of row and j represents your number of column, okay, then that is odd, change the sign of the minor, and if it is even, same as the minor. Is it clear? Let me remove the markings that I already made. Okay, so this is clear, right? This part is clear. How do you understand minors? How do you find minors? What's the relation between minors and cofactors? Okay, good. So this is a 3x3 matrix. This was a 2x2 matrix. How would you find a minor or a cofactor in 3x3 matrix? This we learned. Let's learn this one as well. So if you are, let's say, talking about minor of this one, as I said, remove this row, this column, the remaining element will be in a matrix. Find determinant of that. Okay, that value is your minor of the element M11. Same way, if you're looking for M12, what is going to happen? You're going to remove this column now. You're going to remove that column now. So this will be as it is. Now if you check what elements are left, you have A21, A23, A31, A33. Okay, same thing. Find determinant of this, that's the value of minor. Okay, and if you ask me, so how do you find the cofactor? Same principle. 1 plus 1 even remains as it is. 1 plus 2 is odd, hence sign change. So whatever value of this you're gonna get, just change the sign of that, will become your cofactor for the element A12. Okay, A12. All right. So from here now we get expression for cofactor in terms of minor. This is cofactor in terms of minor. What is it? Simply put, minus 1 power I plus j. If I plus j is even, it will become positive, right? Minus 1 power any positive square numbers, 2, 4, something like that, it will be positive. If it is odd, it will become negative. Negative means sign change. Okay, so I hope this is clear now. Very easy, right? Very easy. Minus and cofactors, please check. Okay, so I think we can move on now. All right, what is the next thing coming up? Of course, after this is adjoint. Adjoint of a matrix. So what is adjoint of a matrix? Of course, for any given matrix to you, matrix A, it will have elements, right? You'll have, if it is 2 cross 2, you'll have 4 elements. 3 cross 3 means it will have 9 elements. That is clear. Okay, so think about it. So adjoint is nothing but you write a matrix of cofactors. You write the matrix of a cofactors of every element, of course, right? See what is written over here? It's not small a11, it is capital A11. It means this represents the cofactor of the first element, right? This is the cofactor of second element, and so on. So you're gonna find the cofactor of each and every element, take transpose on that, and once you do that, you'll end up with your adjoint of the matrix. Okay, clear? Okay, so now of course I'll give you tricks to find 2 cross 2 order matrix adjoint and this, because sometimes what happens, so finding this much of adjoint will take too much of your time. So for that we have this technique. Okay, we have this technique. All right, trick for 2 cross 2 and 3 cross 3 will be discussed, but before that I would like to tell you one more thing over here. As the number of element is n square, remember, minors will also be the same. Think about it. No, in this matrix of 3 cross 3, every element will have its own minor, right? It means that in a 3 cross 3 matrix there will be 9 minors. Okay, the number of element will be same as number of minors, will be same as number of cofactors. Okay, I hope you're getting my point. Number of minors is same as number of cofactors, is same as number of elements. Okay, now trick for 2 cross 2 matrix finding the adjoint. Very simple. I have taken a matrix over here, A equals to 4 7 9 2. Trick is this is the adjoint value. Adjoint is given as, adjoint of A is given as 2 4 minus 7 9. How do I get that? Interchange this value, diagonal you have to interchange. So 2 comes up, 4 goes here, 2 4, and the sign change across other two elements. Other two elements sign change, this interchange. Okay, check here. For this adjoint will be given by, so will be 4 and 12, and for this you'll have sign change, so minus 3 and minus 7. Okay, same way here also adjoint will be given by what? Interchange here, it will become 8 1, and sign change will be 0 minus 5. 0 minus 5. Okay, so this is how you find adjoint of a 2 cross 2 matrix without finding, you know, cofactors and all, okay, this is quick work. Okay, so let's move on to the trick for learning to find adjoint of 3 cross 3 matrix in a faster way and a simpler way as well. Okay, let's start. Okay, now the trick for 3 cross 3 matrix, I have taken an example over here to understand it better, to understand it clearly. Okay, so if they have given a matrix A here, we are looking to find adjoint. Very simple, very simple. Write the same matrix over here. What we have, 2 1 4 3 2 0 2 1 3, and repeat the first two rows again. So 2 1 4 will come here again, 2 1 4, 3 2 0 will also come. So I've written what? I have written the first two rows again. Okay, what about column? Same, first two columns again. So 2 3 2 2 3, 1 2 1 1 2. That's my 5 cross 5 matrix now. This is my 5 cross 5 matrix now. Now in this, next step is to eliminate my first row and first column. Eliminate my first row and first column. Okay. Chali. Next step, cross multiply like this. Vertically you're going to multiply and write horizontally in the adjoint. In this you don't have to take anything or worry about anything for transpose. It's already taken care of. Okay. 2 3s are 6, 1 0 is 0, gone. So answer is 6. 1 4s are 4 minus 1 into 3, which is 4 minus 3, so 1. Here 1 into 0 is 0, 4 into 2 is 8, minus means minus 8. What we are doing here? Subtraction, right? Cross multiplication, 1 0 is 0, 4 2 is 8, again gone. Okay, so 0 minus 8 is minus 8, that's why minus 8 there. Now after we are done with this, let me erase this. Let me erase this just to have better understanding for the next set. Okay, it starts from here. Same way, go vertically downward in the 5 cross 5 matrix, the remaining 4 cross 4 matrix, and write the horizontally in the second row of adjoint. 0 into 2 is 0, 3 into 3 is 9, subtraction will make it minus 9. 3 into 2 is 6, 4 into 2 is 8, 6 minus 8 is minus 2, 6 minus 8, 12 minus 0, 12. Okay, so again we got our second row. Isn't it very easy? Very easy. So now your homework, I want to know what is the third row. Please tell me the value of the elements in third row. Come on, you can do it, right? You can completely do it. I have trust in you. Okay, so 3 cross 3 matrix, how to find adjoint is clear, right? Yes. Now we are moving to inverse, where we use the adjoint part. We just learned, right? We're going to use it over here. So if I have a matrix given as A, we're asked to find what? A inverse. Now this can be 2 cross 2 or 3 cross 3 matrix. They'll not ask you 4 cross 4. Don't worry about that. Okay. Now adjoint of A is what? Of course we can find that. We just learned how to find adjoint of 3 cross 3 matrix. Okay. This part is clear, sir. This part is clear. Very much clear. No problem. No problem on that side. Okay, first thing is to check for the singularity, whether the matrix is non-singular or not. Okay, if it is singular means the inverse does not exist. If you have determinant of A equal to 0, it means A inverse does not exist. A inverse does not exist. But if it is non-zero, then step 1 would be, of course, to check that and find the determinant value that we already did. And step 2 will be to find the adjoint. I showed you how to do it. Step 3 is to use the formula adjoint A by determinant of A. That's it for the inverse of matrix, which will play a big role solving questions in simultaneous equations, even finding the inverse, all those questions. Okay. They're asking us to find inverse of A. It's a 2 cross 2 matrix. We can do that first. Check for this. 6 into 2 is 12 minus 9. Okay, I get this as 3, right? This is non-zero, which is not equal to 0. It means inverse will exist. Let's find adjoint first. Adjoint of 2 cross 2, we all know how to find it. Just reverse these two. So we get here 2, we get here 6. And the sign change for these two. Okay, now inverse formula we all know is adjoint of the matrix A by determinant of A. Okay, so inverse is what? Inverse is 2 minus 3 and 6, and we have divided by determinant is coming as 3, right? So 1 by 3. I can divide inside, right? It will become 2 2 by 3 minus 1 and 2. This is the value of the inverse of matrix A. Please check. So I want to take an example to show you I have done that. Properties of determinants. Properties of determinants. Okay. So I have taken, I think, total 5 to 6 properties, which is part of a syllabus. Let's see. Whenever you have transpose determinant to find, it will remain same as determinant of the matrix. Okay, because transpose will have no effect on the determinant value. So basically what it means is, if you interchange the row and column, determinants A of the matrix A remains unchanged. Okay. Now this is the first property. Property number 2 now. 2 row or column, if they are identical, if you have 2 row or any 2 column, are identical in nature, means they are exactly same. Like here, check this out, this are same, A1, A2, A3, A3, then determinant will become equal to 0. This is the column case, and we have also the row case. Please check here, this first row and third row are exactly same, determinant value is 0. So if you have identical rows or column, answer is for the determinant value is 0. Okay. Now if elements of 2 row and column are proportional, that is R2 equals to 2 R1, like this. For example, here check 4, 6, 9, 8, 12, 8, and what is it, 8, 12 and 18. You can take this 2 common from here, right? It will become 4, 6 and 9 back to, it will get back to 4, 6 and 9. What will happen to this? Determinant will become equal to 0. Okay. So what's the meaning of proportional? It means if you divide this, no, if you divide 4 by 8, 6 by 12, 9 by 18, this all is 1 by 2. That's what the meaning of proportional over here. The ratio remains same for each and every elements. Okay. Got my point? Not required, but just something I wanted to mention over here. Okay. So determinant of A will be 0 if you have proportionality in the elements of any 2 row or column. Okay. Fourth property, if any row or column is multiplied by k, if you multiply a constant k, check here, KC1. So this initially this matrix is actually A matrix. This one A1, B1, C1, A2, B2, C2, A3, B3, C3 is the determinant A. Okay, is the determinant A. Alright. But if I multiply k to the last column, KC1, KC2, KC3, then this will become what? Simply k times of determinant of A. Determinant of A becomes equals to k times of determinant of A. Okay. Now if you have multiplied similarly to all the elements, okay, check, x is multiplied to first row, y multiplied to second row, z multiplied to third row. Okay, then I can take x by z common and write this multiplied with what? With A. Okay, so actually based upon this only this property comes, k power n. Remember, we all know this property, right? If we have matrix B equals to Ka, then determinant of B is nothing but k power Na, where n is what? N is the order. Okay, so if x, y, z becomes equal and they become equal to k, then I can take this as k, right? K power n directly. It will become k cube, no? Please check. It will become k cube. Yes, that's what I'm talking about. So if you have B equals to Ka, it will become k cube. Got it. Chali. So this is clear. Now property number 5. Very useful, directly asked in examination as MCQ. Inverse of the determinant is same as 1 upon determinant value. Please check. Always same. Yeah, this property is also very, very important. If not for the board's point of view, sometimes they also ask this question in the boards as well. But especially when it comes to KCET, this becomes very, very important. In boards, this derivative of the property is used actually. It's a special case when the value where adjoint is coming only one time. Over here we have adjoint coming 1, 2, 3, n times. Okay, adjoint is coming n times on the matrix A. Then the property is determinant of the matrix A, okay, to the power m minus 1. What is m? M is the order. M is the order of the matrix A. M minus 1 to the power n. N represents what? Number of times adjoint is there. Number of times adjoint is there. Okay. So determinant of A power m minus 1 to the power n is the answer for this case. A adjoint of A taken as determinant. Okay. If you have special cases, check here. Adjoint is only once, then the power of m minus 1 will become 1. What's the power over here? Power is 1. If you have adjoint 2 times here, please check adjoint of A. Adjoint is 2 times. It will become power of m minus 1 as 2. Okay. So if you talk about board syllabus, PU2, this is what they usually ask. But in CET, this whole property becomes very much relevant. That's why I have taken it over here as a whole. Is it clear? Is it clear how we are using adjoint and why the powers are different? Okay, let's move on then. Now next is area of triangle. Yes, we have 2 concepts applications in this chapter, area of triangle and solving simultaneous equation with the help of matrix method. There's also Kramer's method, but we don't have from the board's point of view. Okay, I'll teach you that, don't worry. Later we'll see. Area of triangle ABC, 1 by 2 x1 y2 minus y3 x2 y3 minus y1. What is this? Have you learned this? Grade 10? Yes. Grade 10 CBSE, it was there earlier, but later they removed it. ICSE, it's still there. Okay. In the coordinate geometry chapter, we had area of triangle with the help of coordinates of vertex, right? That's this formula. That is this formula. If you have a triangle like this, x1, y1, x2, y2, x3, y3, this is a formula, correct? Okay, super. Now, we can use directly determinant value to get the same result. If you want, you can try it out, okay? From here, find this, x1, you're going to keep it as it is, y2 into 1 is y2, y3 into 1 is y3, subtract them will become y2 minus y3. Same way, if you keep doing, you'll get this result, x1, x2 and x3. Okay, check this out. How do you do it? So write the x coordinates in one place, y coordinate in one place. It's a plane, right? It's a 2D figure, so third value will become 1 1 1. Okay, so area of triangle has a formula with the help of determinant like this. Alright, let's move on. Another application of the same concept we learned right now, which is area of triangle, is collinear point. Now what we do in this, we try to understand here, this is a triangle, right, ABC right now, but if I move the vertex A towards the line BC, what will happen? If I move the vertex A like this it was right now and towards the line BC from here like this, what is happening? Area is decreasing. Area is, right now this is the area, decreasing, right? And there will come a point when its area will become 0 because this will become a straight line. It will become a 1 dimension. Right now it is 2 dimension. Assume that between my elbows there's a straight line going in, right? So right now the triangle is like this, but if you keep moving it like this, the area is going 0 0 0 and there come a point when it becomes very straight line. What happens here? It's a 1 dimension figure now, hence area is going to be 0. So and then the point ABC will lie on the same line, which is called as collinear points. So for the collinear point, what will happen? Area of the triangle will be 0. Area of triangle will be 0. Okay, and from, so we have 1 by 2 over here. I can move on this side, move the 2 on this side. So I'll have determinant of this equals to 0. I'll have determinant of this equals to 0. So basically what happens in this case, no, they usually have a missing value in the vertex. Okay, they'll give you lambda, k, something like that, and ask you to find that value. You'll see that when we go out to our question session, you'll see that how do we actually use this concept of collinearity to find the missing values of the variable. For now, understand this, we use the same area of triangle concept, just make it equal to 0. The lines are collinear, and for that area will be 0, hence try to find the missing variables value. Okay, next up is system of linear equations. System of linear equations. Okay, so I have taken over here two variable case first. This is the two variable case, a1x b1y plus c1. Variable is only x and y. Okay, a2x b2y c2. Variable is again x and y. So let's talk about nature of the equations first. Okay, so nature of solutions first, not equations, nature of solutions. So first one is unique solution. Okay, how do you find that? Also called as intersecting lines. These are also called as, when the line, this will represent a line, right? This will be a line L1, line L2. Okay, you'll have this as intersecting. Okay, whereas this infinite will be a parallel line. Infinite solution, no, it will be not be parallel line. My bad. It will be coincident line, no? It will be coincident line. Okay, we'll get back to solving them, understanding them one by one. Unique solution means what? It means the line will intersect at one particular point. Please check. So whenever you have the coefficients in this form, a1 by a2 is not equal to b1 by b2. What is a1 and a2? b1, b2. They are the coefficient of x and y in the given two equations. Okay. So whenever this condition is satisfied, okay, we call that the given two equations will have unique solution. Sir, why are you teaching this? We have learned this in grade 10. I know, but questions will come on this. Okay, they can ask questions on this as well. You'll see the later form of three variable as well. I have taken over here x, y, z. Don't worry. But right now, understand this very, very clearly. Next up, we have infinite solution. When all three ratios are equal, is called as coincident line case, means when the lines overlap with each other. Okay, and the last one is parallel lines. Okay, when the first two ratios are equal and the last is not. Okay, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2 is the case of no solution. Yes, sorry, I had to take some break. I'm not feeling that well. The weather is like that in Bangalore right now. I'm under the weather, so needed to cough a little bit. Okay, so you see here now we are moving to the case of three variables, a1x b1y plus c1z plus d1 equal to 0. Okay, of course we have three variables involved, so we'll need three equations. If we have two variables, I'll need two equations to solve. If I have one variable, I'll need one equation to solve it. Okay, so if we have three variables here, x, y and z, it means I'll need three equations. Okay, so you'll get a1x b1 by c1z plus d1 equal to 0. Same way you'll get a2x b2y like that plus c2z plus d2 equals to 0, and like this you'll get what? Three equations, of course. And how do you solve that? So of course the nature can also be described with the help of your Kramer's rule. Okay, but I don't think it's there in your syllabus right now, but if it is there, don't worry, let me know. If it is there, it's not big deal actually. What you do know, you find the matrix here, the determinant value of this matrix a1 b1 c1 a2 b2 c2 and a3 b3 c3, and then you also find the matrix dx, okay, dx dy dz, and use that condition to understand whether it is unique solution and infinite solution or not. Okay, we'll see that. If it is there, I'm telling you, if it is there in your syllabus, let me know in the comment section. When I come for the quick revision before examination, I'll teach you this again. Okay, so let me know. But right now we'll use matrix method. For now we'll use matrix method to solve it. Why I'm telling you this? Because in exam they very clearly mention that in the question, okay, that you have to solve the question with the help of matrix method. They explicitly mentioned it to you. You have to solve with the help of matrix method. Okay, got it? Check this out. So what is the meaning of matrix method? This is the matrix method. This is your matrix method. Check this out. If a1 b1 c1 a2 b2 c2 a3 b3 c3 is the constant, sorry, the coefficient of x, y, z from the three equations I've taken over here, that's my equation. a1x b1 by c1 z equals to d1 a2x b2y c2z equals to d2. Basically it is plus d1 only, not equal to, excuse me, plus 0 0. Okay, so you write this in this format. Okay, you write in this format and you check a1x b1y c1z, you're gonna get the same thing. Okay, you're gonna get the same thing. It was actually in the case of, so it will become minus d1 minus d2 minus d3. So it was actually the same case what we did earlier, equal to d1 equal to d2. Okay, so my point is they can have in any fashion, no worries. Let's maybe make it that only. Why to confuse you guys? It was actually the case of what we wrote earlier. This was the case. Please check. a1x b1y c1z equal to d1 is the first equation. a2x b2y c2z equal to d2 is the second equation. Okay, and so on. Third is here a3x b3y c3z equal to d3. So you write this equation in this format. The first one is the matrix, a 3 cross 3 matrix of the coefficients. Next is 3 cross 1 matrix of the variable, we call it as the matrix X, and the last is 3 cross 1 matrix of the constant. Okay, of the constant, we call the matrix to be matrix D. Okay, now I want to find the value of X, right? I want to find the value of unknowns. So you're gonna do what? Find inverse of A. If you apply inverse over here, this will become I and this will become A inverse into D. So find inverse of A, multiply it to D. How do you find inverse? You know that. Check it should not be 0 and find the adjoint and all of that. I already taught you all of that. So finding inverse is very simple. You all know that. Okay, so finding inverse, after that put it over here, multiply it with the matrix D. That will be the answer for X. Okay, that will be answer for X. This is the matrix method. Now in the knowledge hub, before I end this class today, in the knowledge hub, before our completion of rapid revision, couple of things to remember. Very rarely asked, but if it is asked, takes too much time to solve the questions. That's why I'm giving you this in knowledge hub. If you know this, if you have this knowledge, if you have this information, then what will happen? The question becomes very simple. Check. So something called a cyclic determinant. Whenever you have the elements in this format, ABC, BCA and CAB. ABC, BCA and CAB. It's a cyclic order, right? Check this out. A, B, C. First is ABC, second is BCA, then it is CAB. It's a cyclic order. Okay, so whenever you have this in this format, it's called a cyclic determinant. This determinant is given by simply minus of AQ, BQ, CQ minus 3ABC. There's a minus sign outside. Okay, there's a minus sign outside. Remember this directly results. This result you can remember directly, will be time saving for you. Okay, remember this is the formula actually we learned in grade 10. Entity. A plus B plus C, the A plus B plus C, remember, times of A square, B square, C square, minus AB, minus BC, minus CA, yeah, that one. Now, this is for skew symmetric matrix, very important, very, very useful in MCQs. For skew symmetric matrix they have given to you, if it has the order as odd, odd means 3 cross 3, 5 cross 5 order is given to you, answer is always 0 for determinant. Skew symmetric matrix of order 3, order 5 will also always have the answer as 0 for determinant. Remember this property. Very, very important. The two important property that I want you to remember, cyclic determinant and skew symmetric matrix with odd orders. Okay. This completes your session in the rapid revision of your chapter determinant. If you're new to the channel, subscribe right away if you want to be taught in the same fashion, if you want to learn something, if you want to improve in your studies, and there are many more things coming up for you guys. We'll be here till the end of your journey, until you go to your college. We'll be here to help you out, okay, in every way possible. Any queries you have, let us know in the comment section right now, and I'll be back in your next session of One Marker, where we'll solve the questions on this particular concept of determinant. Okay, so with this I can end the session today. I'll see you again very soon in the next session. Till then, take care. Bye bye.